Hello, my name is Alex Bacon. I'm with Group 17. My other team members are Thomas Cole and Sai Pranav Angol. Our data set is car accident data from 1997 to 2002. It is mostly categorical with numeric values representing each category. Here's the key for each column vector. You can pause the video and look over these. As an example, dbCAD is impact speeds 1 to 9 kilometers per hour is represented as a 1, 10 to 24 kilometers per hour is represented as 2. Again, it's categorical data with numerical values set to each category, such as injury severity. 0 means you weren't injured, 3 means you were incapacitated. You can pause the video and look at that. Here's the all of our data set. Each one of these column vectors is 26,000 roughly points long, and most of these are binary. The only linear data sets are year of the accident, year of the vehicle, and then age of vehicle, which is a derived column vector. Moving on to the program. Since this program runs off a bunch of 26,000 column vectors, has an incredible amount of memory requirements. So a memory requirement message box is brought up in case a grader is using a machine that's too slow. And it just says you need this minimum of memory to run the program. None of the column vectors are loaded in the main. They're all run as local variables in each function. And they're run in the function, kept as local variables, and then dumped immediately afterward once they're done. The main menu is done through a cell vector-based menu. Each cell vector corresponds to a value. Values are represented in these case statements based on C. The user inputs the value of C, choosing the menu option, correlates to a number, correlates to a case, runs. Each of these is a function. Moving on to the first function. This reads through the dead column vector and just reads off. If there is a 0 or 1, 0 is live, 1 is dead. It gets the percentages of how many people lived and how many people died in our entire data set. Here's the Excel read, grabbing the Excel file name, the sheet number, and how much of the column, which is almost all the entire column, assigns it to this local variable. This is just getting a number, initiating your variables, doing a for loop with the condition. It reads if the person died, gets a total dead. Just through some statistics, you can just -1 this. Get the percent dead, get the percent alive. Reads off these numbers here to give you some perspective. It represents this in a labeled pie graph. The labels are just a cell vector, and it just gives you the percents of people lived and died. The next one, worst case, it takes some time to load. This is a lot of column vectors being read. Each one is, again, 26,000 data points long. It takes a long time to load this particular function, and why each function gets its own data. This is initializing a bunch of variables. This function goes through every single subcategory of each category and obtains the number of counts of how many times a subcategory occurred in the category. And that's all these just getting counts through just nested loops, a switch case and a case. So this is the subcategories for this one. This is you have an airbag installed or you don't have an airbag installed. And this is counting that and going through the entire column. This checks if those same categories, but if a person died at the same time. So case is switched out with if else. Check if that condition happened and person died in the accident. And you can see death percentages of all those subcategories through just dividing and timesing. So you get the worst case scenario, which is just spelled out to the user initially. So as you can read there. And then there is a bar graph that is presented to the user using all these death percentages. and it gives you every category and every subcategory and what that death percentage or chance of death is in this entire graph. You can pause, take a better look at it. And here's the bar graph. So the bar graph just gets all these death percentages calculated up here. This is all the labels. Sets you up a bar graph. X-tick labels them all using this cell vector, and you just get a message box that gives you what the greatest chance of death, which is all the subcategories put into one if statement. Moving on to the next one. Linear 2D plot. This is just the year of the vehicle versus a count of how many people lived or died based on the year of the vehicle. Again, you get counts for how many times these subcategories happened, if the person died, if they lived. So this is lived, this is died. You use a indexed vector to assign each year of a vehicle or each age of a vehicle, and then how many people died and how old that car is. And it just gets counts based on nested for loops and then an if statement to go through the conditions. Then there's two subplots, as you see here. Take a better look at it here. So this is the age of vehicle in years versus how many people the counts of how many people lived, the counts of how many people died, then a 8th degree trend line showing you what the trend is. And here is the trend line is in here somewhere. Here it is. Polyfit, polyval to give the trend line, just based on the previous data. Relative risk. Here we go. And that's the end of that function. Close this. Relative risk is a pretty simple program. It just shows you what the death percentages between men and women are. Come up. I had to run this. Usually bar graph should come up. Anyway, this reads here we go. So this reads these two, imports these two column vectors into variables, initialize variables, scan through them for these conditions, get your counts of how many males there are, how many females there are in the data, how many of them died, divide themselves, get yourself some risk percentages, gets you this bar graph, male, female, their chance of death in an accident. And all that is put into a labeled bar graph. Finally, probably the biggest is this function gets you a bunch of histograms of the entire data set. So it load most of the categories. And in one line, a secondary menu is popped up. And in one line, you can basically choose which histogram of the data variable or column data you want and how many times a subcategory within a category occurs. So in this one line, it makes a histogram categorical data within this column vector, which is here's the category, here's the subcategory numerical values, and then here's the labels. So this is basically the bin labels, and this will have the counts for them, and then their titles and whatnot. So if I wanted the counts of every subcategory within this category of speed, here's how many times it occurred within the data. This should all equal up to a total count of 26,000, as it's every point. So you can see how often these occurred, what their trends look like. So these are just occurrences within the data. So how many years old the driver and passenger were, if they had airbag that deployed, what kind of injury they sustained. Most of these Oops. Continuing on. So this is the age of the vehicle, how many times it occurred. So most vehicles are, either leases or 3 to 5 years old. So most of this data corresponds accurately to actual statistics of accidents and vehicle data, which seems reasonable because we're working with such a large data set. Well, it's only pertinent for 1997 to 2002 still. So this is a looping menu, while option. You just click the last option to exit, go back to main menu, which is, and so it exits this. It goes back to the main menu, which is also just a perpetually going switch case loop, which why the menu is always up here. It's just constantly running this over and over again after each choice, and each function runs and ends. So, concluding, click exit, kicks you out of the loop. So, in conclusion, our group dealt with a lot of non-linear data, and it was almost all of it was categorical, which made getting linear data very difficult, and using bar graphs and histograms very useful in getting good graphics for the data and describing the how the data is, how it trends, and where the majority of the categories and subcategories are. So we learned a lot about searching through and sorting through categories and subcategories of the data, and using a lot of if-else to get your conditions of what to sort through, and indexing to index counts based on like your vehicle and other such things, and a lot about bar graphs and histograms of how efficiently to display those, and how to display multiple categories and multiple bars within one category, within an entire bar graph. And that's pretty much it. So what else did we learn? It was a lot of work. There was almost every for loop was just a nested for loop, or a nested for loop